Okay, this is the second of two videos for this day of notes. We're talking about area, and specifically we're talking about circles and sectors. Video number 2 here, the last video was just basic circle stuff, pi r squared for the area of a circle. This time we're going to talk a little about parts of a circle, right? What about a piece of a circle? So first of all, let's talk about what's called arc length, okay? What I'm interested in then is what is the distance along the arc? Okay, and when I say that, I'm saying if I walked a path from A to B along the curved circular route, that's what I'm interested in. What is the length? What is the length of that arc? Well, here's what I know. I think the best way to look at this, you could go and memorize the formula, and that's all great. Okay, you could memorize the formula, but I think it's easier to understand that really that's just a portion of the perimeter, right? That's a piece of the perimeter. And how I find the perimeter, which we call the circumference of a circle, okay, that's a portion of the circumference. How do I find the circumference of the circle? Well, I can take pi times the diameter, right? Or, because the diameter is really twice as long as the radius, I can replace the d with 2 times r, and I get the same thing. So then let's go up here and let's say, well, what if I have a portion of that? Well, really, that's just finding out like what percentage of the circumference did I travel to get from A to B. Well, that's where this comes in, okay? I know that a full circle is 360 degrees, so if I travel a portion of it, really what I'm interested in is this. How much of that portion did I travel? That's some number out of 360, right? So if this is a 120 degree angle, I traveled 120 out of the 360 degrees. That tells me what percentage I traveled. And then I just take that times the full circumference, right? You see that? That could also be pi times the diameter, right? So really it's just a percentage times circumference. The reason, by the way, arc length, we use L to represent arc length in our math vocabulary, okay? So let's do a few problems. Oh wait, no, sorry, I got another formula for you. How about the area of that shape? What if, now notice, same thing here, I could transfer this m, they're the same idea, okay, those are the same number. What if I travel a portion of the circle from A to B once again, okay, so the arc length would be this circular distance from A to B. I could also find the area of a wedge shape, like a piece of pie, right? But the formula is almost exactly the same. Look at this. I could name that sector ACB. Sector ACB would be the way that I name that. You see that here? And the formula, look at that. A full area is pi r squared. We're going to do a portion of it. How much of the 360 degrees? Right? Does that make sense? So let's go do a couple of problems. I'm booking along here. Feel free to pause at any point in time. Find the area of sector EFG, for example. Well, here's what I know. If that was a full circle with a radius of 6, that the full area would be pi times 6 squared, which would be 36 pi. But I didn't travel the whole circle, so I don't want to know what the whole area is. I want to know what a portion of the area is. So I'm going to take that 36 pi. I know that I went 120 out of the 360 degrees, right? So if I take 120 out of 360 and I multiply it by the 36 pi, that should give me the area of just the blue piece, right? Well, 120 out of 360 is really 1/3. So if I take 36 pies and cut it in thirds, that means each one of those, 36 divided by 3, would be 12. 12 pi, that looks like centimeters, so the area would be square centimeters. All right? The full circle is 36 pi, so the portion that I'm interested in is 1/3 of that, which is 12 pi. By the way, if I took 12 times pi on the calculator, I would get about 37.70 square centimeters. Okay, there's an approximate. Let's find the area of this one here. Okay, if I looked at the full circle with a radius of 3, I'm going to take pi times 3 squared, pi r squared. For the full circle, 3 squared is 9. So really, I have 9 pi for the full circle, right? Well, I didn't travel the whole circle. I traveled 80 out of the 360 degrees. So I come over here and I say, well, I'm going to take 80 over 360 times that 9 pi. Now, if you go and you do 80 over 360 on your calculator, you'll notice that it gives you 2/9. This thing right here, that fraction right here, is really simplifies down to 2/9. My calculator told me that. So if I took 2 over 9 times 9, you'll notice the 9's go away. I'm left with just the 2. And don't forget the pi here. We'll just transfer the pi over. 2 pi square inches. Okay? It's easiest, by the way, you're going to find out when you're doing these problems. The easiest thing to do is forget about the pi until the very end. Just throw it in the answer. Okay? Work with all the numbers, the 80 and the 360 and the 9. Work with those without the pi first. Okay? And that'll get you the exact answer. I'm interested in what am I going to have to multiply times the pi in order to get my answer, right? If you take 2 times pi on your calculator, you're going to get 6.28. Makes sense, right? Double of 3.14. That would be square inches, by the way. That'd be approximate. So we're going to look for equal signs and approximate signs, aren't we? Looking for double squiggly so we know when we can round. Here's a couple of tougher problems, and then we'll be done. Find the radius of that shape, right? Here's what I know. I have sector A, B, C, and it's 9 pi. Well, let's see here. That means this yellow section here is 9 pi. So if I add it over here, that's 90 out of the 360. That's a quarter, right? So the full circle would have an area of how many pies, right? Well, that would be 36. It looks like 9, 18, 27, 36 pi. The area of this circle total is 36 pi. Well, if area is equal to pi r squared, and area is equal to 36 pi, that means these two things on the right are equal to each other. 36 pi must be equal to pi r squared. Pi's go away. R squared is 36. The square root of 36 gives me 6. So all I know, I don't know what the units are. I'll just put units. Okay? But the area, the radius is 6 units total. Easy problem, right? Not too bad. All right. Find the arc length of if the arc length is 6 pi, if this is 6 pi, then find the area of the sector, which is this shaded area here. Okay? Find that area if I know that the arc length is 6 pi. So here we go. First things first. If that's 6 pi and it's 120 degrees, here's what I know. That I got that 6 pi by doing 120 out of the 360 degrees. That's the portion of the circle that I traveled, and that's out of the total circumference, right? So I can either put pi times the diameter or 2 pi r here. Okay? Some portion of the circumference would give me 6 pi. Well, let's go ahead and let's try to simplify things down. Okay? First of all, notice the pi's go away. Only variable I'm left with, that was the only variable in the beginning, was an r, right? How do I simplify that down? Well, this is 1/3. 6 is equal to 1/3 times 2 times the radius. Okay. I would multiply by 3 both sides. Okay. So now if I take and I multiply both sides by 3 times 3 here, the reason I would do that is because 3 times 6 is 18. Great. But 1/3 times 3, those go away. So I'm left with the 2 and the r. How about that? Looks like the r is equal to 9. The radius of this shape is equal to 9 units. So now, here's what I know. The full area of the circle would be pi times 9 squared. The full area of the circle would be 81 pi, right? But I'm not going the full circle. I'm going 120 out of the 360 degrees. So let's take the full area. Let's multiply it by 120 over 360 to find which portion of that 81 pi we're talking about. And so if I do that and I simplify everything but the pi, this is 1/3. 1/3 of 81 is 27. That's what a calculator is for. You can do that. So the portion is going to be 27 pi square units. All right, a couple more. I think I've got 2 examples left, both off the ACT. Oh, last example. If the radius of the circle below is 4 feet, what's the area of the shaded portion of the circle in square feet? Okay, well, let's look at the total circle, right? If the total circle would be pi r squared, which is pi times 4 squared, and 4 squared is 16. But you know what? I'm not interested in the whole circle, right? It looks like that's divided evenly into fourths in my mind. So what I would do is I would say this: if there's 16 pi, that means there's probably 4 pi here, and 4 pi here, and 4 pi here, and 4 pi here in each of the 4 segments, right? Can't really see that, can you? Kind of dark, okay? Each of these segments has an area of 4 pi, so the shaded area would be 4, 8, 12. It'd be 12 out of the 16 pi's are shaded, right? Makes sense. It's 3/4 of a circle. Here's what they really want you to do. They really want you to notice that it was 3/4 of pi times 4 squared, right? Pi r squared is 16 pi, 3/4 of that. We could simplify it down and get 12 pi. However approach you want to do it. All right, that's it for the videos for today. Hopefully that's good enough to get you a pretty sound understanding on circles and sectors so you can come in next time and do some homework.